Hello, I'm Frank Lehman. I'm the founder of Specialty Testing Dvelopment Company, Inc., and the inventor of the split-strip test method for evaluating internal deposit stress in applied metallic coatings. I'll be illustrating for you today how we do that. I would like to begin by saying that this test method has the approval of the American Society for Testing Metals. We have a designation B975-15, standard test method for measurement of internal stress for applied metallic coatings, deposit stress analyzer method. We market this method worldwide, and it's an excellent, very inexpensive way to determine the stress values of the coatings that you may be applying in your business. I would like to begin by showing you what a test piece looks like. It's a simple split strip, as you see, has two legs, and in the plating process those legs are going to move, indicating the stress that's being applied in the coating itself. As you can see, this test strip is plated. One side plates, the opposite side does not plate. In this case, the stress is tensile in nature, meaning that the strip has bent, the legs have bent in a way that the outside surface is the plated surface. For compressive stress, the opposite happens. You plate the test strip, and the outside of the test strip leg is not plated, the interior is. A typical leg spread can be anywhere from 1/16 of an inch to about 1.25 inches. Don't want to exceed the 1.25 inches because you start to stray from the actual test value in that situation. And it has a scale that shows the degree of spread, and you read that reading by supporting a test strip with this section.
The test setup. Plug the rectifier into the automatic timer, which is plugged into a 120-volt source. Place the anodes in the plating cell anode pockets and connect the red leads to the anodes. Place the heater in the 800 series plating cell. Set the pump to its lowest setting. Dampen the suction cups on the submersible pump and fasten it to the side of the cell so it rests on the bottom with its side located 1/2 inch from the cell end wall and the outlet directed toward the cell wall opening. Fill the cell with the plating solution to within 1/2 inch of the top of the cell. Plug the heater into the temperature controller. And plug the pump into a 120-volt source. Heat the plating solution to the operating temperature. Then connect the red positive lead from the power supply to the aluminum anode contact provided on the cell. After following the test procedure for cleaning the test strips, you will then use the black negative lead to fasten a test strip to the stainless steel support mounted on the cell.
In mounting the test strip, about 1/8 inch of the test strip piece should be above the crossbar when you're attaching the strip, and the contact lead from the power supply supports the test strip
The test procedure. Soak a test strip in a soap cleaner solution at 110 to 120 degrees Fahrenheit for 30 seconds. Then water rinse. Immerse the test strip in a 10% by volume hydrochloric acid solution for 15 seconds at room temperature, then water rinse. Then alcohol rinse. Dry the test strip completely. And weigh the test strip. Record its weight. Clip a test strip to the stainless steel cross support to have the test strip centered between the cell walls. The test strip legs should be approximately 1/16 of an inch from the plating cell bottom. Using a test strip that has been used before, turn on the power supply and adjust the desired amperage. For example, nickel would be 30 amps per square foot at a current of 0.25 amps for a plating time of 4 minutes and 12 seconds. This would produce an average nickel coating thickness of 100 microinches. Remove the sample test strip and replace the weighed test strip and begin the plating test. Replace it with the weighed test strip and begin the plating test. After the test strip is plated, remove the plated test strip from the plating cell. Remove the plated test strip from the cell. Rinse the test strip in water, then rinse it in alcohol. Dry the test strip with a paper towel. Place the test strip on the measuring stand. Remember to read and record the total increment spread on both sides of the zero as the value for U. And weigh the test strip. Record its weight. The Insight 1 plating cell procedure. For the purpose of this demonstration, tank anodes can be used, or an anode basket for a lab setup. The Insight 1 cell can also be used in a production tank as long as the windows see the same situation in regard to the anode size, shape, and distance. You would clean the test strip as per the previous video. Clip the test strip to the negative black lead in the Insight 1 plating cell. Make certain that the test strip legs don't protrude through the cell windows, but rest on the bottom of the cell. The test strip should be centered in the cell. Then connect the positive red lead clip to the anodes. Plate the test strip.